independent, write it out, and dependent events. We're doing like short form notes. Writing this down. This isn't the last day.
Last lesson?
We're going to do loads on the, I just said loads. I put lesson in notes together. What just happened there. All right. So, the key thing, yep. You're just writing with your hand. Okay. Independent and dependent events. So, you need paper. When we did mutually exclusive and not mutually exclusive, oh my gosh, stop. Just go. Just go for it. No, like, we're waiting now. Now we waited. And nothing. Okay. So when we did mutually exclusive and not mutually exclusive events, one thing was happening. I was always doing one experiment. Hi, please. So I was taking out a card and I was asking you what's the probability it's this or this. Or I was rolling 2 dice at the same time and I was saying, what's the probability it's this or this? Or I was flipping a coin. Or I was doing one thing at a time, right? One thing, and then it was probability it's this or this. If there was overlap, it was not mutually exclusive. If there was no overlap, it was mutually exclusive. Independent and dependent events are at least 2 events happening. Or at least 2 experiments, I should say, happening. So at least 2 experiments happening, and I'm going to ask you for the probability with an and. So the probability of something and B happening. So that's where we're going to get a multiplication in there. Now, how could this look? It could be like, I take out a card. So, at least 2 experiments happening, and then something and something. So it might be like, I take out a card, and then I choose another card. So now I have 2 cards in my hand, right? What's the probability the first one is red, and the second one is red? Or the first one is blue, and the second one is pink. Because remember, they don't have to give you a card. Often if they actually give you cards, they'll make up a whole new deck. All right. So what would make it independent? Independent is when the events don't affect each other. Independent. That is not what I meant. Isn't it Dant? Independent. Isn't it? That's Dant. Independent events are when the 2 events don't independ. No, my gosh, look at that. It's Dent. Type it into your phone. It's bothering me. I thought it was Dant, but then I'm writing it's Dent. Independent, isn't it? A? It's an E? See, now you can see why my head wasn't working with it. Okay. Independent events are 2 events that are not affected. So, that don't affect each other. 2 events that do not affect each other. So things that are always independent are spinners. Well, let's pretend that's equal. So I have a 3 spinner. This is red, blue, pink. So if I said I spin the spinner twice, what's the probability it's pink and then pink? So do I take the spinner piece off and get rid of a pink piece when the first one's pink? No, you spin the spinner and then you have equal events again to spin again. So that's completely independent. It doesn't matter if I get pink the first time, I still have the same chance of getting pink the second time because I don't take a piece off. Another thing that's always independent is a coin. Because one side's heads, one side's tails, right? So I'm like probability of getting a heads and then I flip the coin again and getting a heads again. Does it matter that I get a heads the first time? Does it affect it the second? Do I take the piece of the heads off the coin and now I only have tails left? No, I can't physically take it off. So the next time, I have all of them back again. So spinners are independent, coins are independent, dice. Like if you roll a 6 the first time, you can still roll the same chance of getting a 6 the next time because you don't take that 6th piece off. What about cards though? What if I go in a deck and I take out a card and this one's a king, and then I take out another card? Would the second event depend on the first one because I'm holding it in my hand? Yeah. So cards aren't always independent. Same with if you have marbles in a bag of marbles, and you take a pink marble out, and I keep holding on to it, and I pull another pink marble out. Now this one's actually different. If there was 4 pink marbles, it would be like 1 out of 4. And now it would be 1 out of 3, right? Because I'm holding it. So spinners, coins, and dice are always independent. Cards, marbles, all those are independent when it says with replacement. If I replace the marble or I replace the card in between pulling out the next one out of the bag or out of the deck, then it's independent, right? Like if I take out a king and then I put it back in, I have 52 cards again. It doesn't affect it at all. So if I replace the card back into the deck, it's independent. The events are independent of each other. The second one does not depend on the first one, right? So spinners, coins, dice are always independent. The two events don't affect each other. Cards, marbles, you have to replace it. Or if you had 2 bags of marbles and you pulled the first marble out of bag 1 and the second marble out of bag 2, it doesn't matter if you don't replace the first one because I'm taking the second one out of a completely different bag of marbles, right? So independent events means that the second event doesn't depend on whatever the heck. I could actually find the second event first and then the first event second, and it wouldn't change my probability because they don't affect each other. Do you know what I mean? So, for example, if I said the probability on a spinner, this spinner here, the probability of getting a pink and then a head on a coin, probability of getting pink would be 1 out of 3, and means I multiply, and a head on a coin is 1 out of 2, right? Now what if I did them out of order? 1 out of 2 and 1 out of 3. I would get the same thing, wouldn't I?
Yeah.
That's when you know they're independent. They're independent when you can do them this way or you can do them this way and you get the same answer. Okay? Now, dependent events. The second event affects the first. So basically, the second event depends on what I got on the first one. That's why it's called dependent. The second event depends on what the first one was. And a lot of this is without replacement. That's the big thing. And a lot of these are like cards. Something like that. Cards, marbles, something like that. So if I had the probability of getting a king and a 2. So a king and then a 2. Not a king and a 2, like the card is a king 2. There's no such thing. I'm taking out one card and I want it to be a king. And then I want the second card to be a 2 without replacing it. That would, they would have to have that in the question. Without replacement. Right? So I would do the probability of a king. And now this is why the dependent looks like this. There's this bottom equation. This is the dependent one. It has like B/A here. What the heck does that mean? Well, it means, okay, I need the probability of a king, and I do this when it's dependent. I need the probability of a king, and then I need the probability of a 2, given that the first card was a king. That's what that means. That's what that slash means. You know, taking out a 2, but the first card is a king. I'm holding a king in my hand. That's what this means. So it changes what it's out of. Not how many I'm choosing from, because there's still 4 2s, right? But instead of 52 cards, I'm now choosing out of how many? I'm holding a king. 51. So this would be 4 out of 52. And then this would be 4 out of 51. It sometimes changes the top. When would it change the top? When would it knock the top down from 4 to like 3, let's say? If I asked for the probability of what? A king and another king. Then it would be 3 out of 51, right? Like it would knock down the top because I'm holding a king. Like it's whatever I'm holding. So this one here says, okay, probability of a 2, given that I'm holding a king. Okay, I'm holding a king in my hand, out of a deck of 52. How many 2s do I have? Well, I still have 4 because I'm holding a king. How many cards do I have total? 51. Okay, that's all this lesson really is. That's it. So let's try some examples. Okay, so I have a box of marbles. A box of marbles. If I have one bag of marbles and then another bag of marbles, and I take one out of this bag and one out of this bag, then they're independent of each other, right? 2 totally different events. Okay, so I have a box of marbles. If I pull out one marble, it's going to be mutually exclusive or not. That's it. One event goes into mutually exclusive or not. What's the probability it's blue or it's pink, right? If I take out a marble and then I take out another marble, now it goes into independent-dependent range. What's the probability it's blue and the second one is purple? They're very different. One marble, then another marble. Gets you into totally different lessons. One's independent-dependent, one's mutually exclusive, one's not. Okay? So we have a box of marbles. There are 5 purple, 3 green, 2 orange. Two consecutive draws are made from the box. Consecutive means one after the other, right? So I take a marble out and then another one. Oh, now I'm in an independent-dependent lesson, right? What do I need to include here? Before you can even tell me if this is independent or dependent, I haven't given you enough information. Taking out a marble and then I'm taking out another one. What do you need involved here? What's your question you asked me? Yeah?
Will you keep the marble out?
Will I keep the marble out or not? If I replace the marble, the 2 events are what? Independent of each other. If I replace it in between, right? If I don't replace it, the second one depends on what I'm holding in my hand on the first one, right? So I'm going to say without replacement. So the probability of I'll be right back to that. A, purple then purple. And then B, green then orange. You do those. Try and write it out with the formula, with the slash. We have probability of purple then purple, so we want to write it out properly. So we have probability of purple and purple. How do we write this out when it's dependent? We go probability of purple and probability of purple. Given that, the first one is what? Purple. So it's actually writing the format out, right? So how many purple are there? 5 out of 10 times purple, given that I'm holding a purple. 4 out of 9. So it's 9 out of 90 or 1 out of 10. Remember that the amount is out of also reduces, right? Green then orange. So probability of green and orange equals probability of green times probability of orange, given that there was a green. So how many greens are there? 3 out of 10. Now oranges, 2, but I'm holding a green in my hand out of the total. So it's 2 out of 9. So 6 out of 90 or 2 out of 45. No, 2 out of 30. Don't know why I'm writing 45. Yeah.
Isn't 5 times 4 in the top 20, or we?
I did this earlier today. I did 2 and 3. Sorry, I did 4 and 2 and wrote 6. But 4 times 2 is 8. I'm on a roll. Yes. 4 times 5 is 20. So it's 2 out of 9. Oh, that reduces the whole thing wrong. 2 out of 9. All right. Okay, we're doing a deck of 52 cards. A king and then red without replacement. B 4 and then red with replacement. Sorry, this should be king and then not red. King and heart. Do that. Not king and heart. You can't call. I'm going to make it hard because I'm going to make you have 2 cases if I do it that way and they don't make you. Let's do king and jack. So here we have without replacement. What does that tell us? It's what? Dependent. Means I have to have that slash in my formula, right? Because I have this and I'm holding it in my hand. So I'm going to have probability of a king and a jack equals the probability of a king and means I multiply. Probability of jack given that the first one is a king. So what's the probability of a king? 4 out of 52 and means I multiply. Then a jack given that I'm holding a king? 4 out of 51. What does that reduce to? What did you get?
4 over 662.
Okay, then this one says 4 and red with replacement. With replacement means it's what? Independent. So I'm going to have probability of a 4 and a red. This one's easier to write out. It's just probability of 4 times probability of red. That's it. Right? And it's a red given that what? It doesn't matter. It doesn't matter what the first one was because I replaced it. So probability of a 4 is 4 out of 52. Times probability of a red, 26 out of 52. It doesn't matter if the 4 was red, right? At all, because I replaced it. What does this reduce to? 4 out of 52 times 26 out of 52. What'd you get, Ryan?
I haven't turned into a fraction, but I got 0.03
Yeah.
or 0.039.
0.039? And sometimes they might ask us to the nearest hundredth. If they ask us to the nearest hundredth, we wouldn't give a fraction. We would give 0.04. If they ask us the nearest percent, we'd say 4%. Oh no! Hey, grab. On the bottom, swing bottom. Hit the book. Brad was saying, you're saying you're nice, I'm saying you're safe. You're saying you're It's true. Could be worse. Okay.
Rewrite my notes.
Yeah. Example 3. This is the last type you could get. Okay? Yeah. Yeah. So example 3 is where you're given a piece of information. So here it said, Connor is planning a weekend trip. So Connor's planning a weekend trip. And then it says he is considering canceling the trip. If the weather is wet. The probability of a wet day is 0.3. So he's going for 2 days on this trip is what they would have to say, okay? So what's the probability? He won't go on the trip if it will rain at all. Let's say that. So what are our options if he won't go if it will rain at all? He's going on a 2-day trip. What are the options that would kick out him going? Probability on the first day that it rains and the second day that it what? Rains. Okay, that's 1. Or, which means I'd add, what are my other options? Probability of what on the first day? Raining. And no rain on the second day. Still wouldn't go because doesn't want to go if there's any rain. I have another option still. What would it be? Probability of? No, if there's no rain, he would go. What's the other option?
Oh, like not raining the first day.
Not raining the first day and raining the second. Because those are different, right? The second and the third are different. So guys, if it's a probability it'll rain is 0.3, what's the probability it won't? 0.7, because complements add up to what? 1. So probability of rain is 0.3, probability of not rain is 0.7. So I'm going to go probability of rain. I'm going to go 0.3 times 0.3 and get an answer. And then probability it rains and doesn't rain, 0.3 times 0.7. And then not rain then rain, 0.7 times 0.3. One of those days. So this is 0.09 plus 0.21 plus 0.21. So that's 0.51. So you don't need to be given a whole bunch of other things as long as you know that complements add to 1, right? Okay. Here's one to try. So here is just, I'm going to read it to you so you don't have to write the whole thing. In a game of field hockey, the probability the Dinos score a goal from any short corner is 1/8. So the probability of scoring a goal determined the first half, during the first half of the match, they awarded 2 penalty corners. So they get to do this twice. They get 2 penalty kicks, basically. Use a probability tree diagram to determine. Well, I want you to tell me, what's the probability the Dinos will score and then score? Score only once. Not score at all. So the probability they will score then score would be 1/8 times 1/8, which is 1 out of 64. Score only once. This one you have to watch yourself, because they could score then not score, or not score then score. You get cases, right? So this would be score and not score, or not score and score. So it's 7 over 64 plus 7 out of 64, which is actually 14 out of 64, or 7 out of 32. And then this one's not score at all, so I would just go 7/8 times 7/8, which is 49 out of 64.